Welcome to the video abstract of our work, Efficient NIZKs and Signatures from Commit and Open Protocols in the QROM. My name is Jelle. This is joint work with Serge, Fehr, Majenz and Schaffner. I'll start by explaining the words in the title of our paper. Commit and Open Protocols are a subclass of the three-round interactive proof systems, also known as Sigma protocols, where in the case of commit and open protocols, the prover in the first round commits to a number of messages via a hash-based commitment scheme, which we can model as a random oracle in order to do a security reduction. And then as a next step, we may apply the Fiat-Shamir transformation to obtain NIZKs, non-interactive zero-knowledge proof systems, or digital signature scheme. Now, to prove that such a scheme is online extractable in the quantum random oracle model, what we do in our work is adapt an existing framework of QROM simulation to construct an online extractor, where online means that the extractor is given only black box access to the prover, then runs it just once, so no rewinding, while at the same time simulating the random oracle in order to answer queries of the prover. Then if the prover is successful, the extractor produces a valid witness, all in such a way that the distribution of the output of the prover while interacting with the extractor is close to the output of a prover in the normal run. Using our technique, we obtain a tight reduction. Tight in the sense that if the attacker has success probability epsilon, our extractor also succeeds with probability epsilon up to a negligible additive error term. Whereas the generic reduction that applies to any type of Sigma protocol has a loss of epsilon cube over q to the sixth. Which in a previous work we managed to reduce for this specific class of commit and open protocols to just epsilon over q squared. But now getting rid of the q squared factor, we obtain the first tight reduction of a Fiat-Shamir based NIZK or signature scheme in the QROM. That's the main result of our work. We further show that this reduction also works on commit and open protocols that use a Merkle-tree for the commitment that allows for a special so-called Octopus Opening, which is just a more clever, more efficient way of opening multiple values at the same time. If you want to study this in more detail, I invite you to either pause the video or read the paper or come to our talk at the conference. And as another extra result, we show that the Unruh transformation, which is comparable to but less efficient than the Fiat-Shamir transformation, but it was the first NIZK that was provably secure in the QROM. It's also online extractable. It has the advantage that it can be applied to any Sigma protocol, but the prover has to commit to a single response for every possible challenge, making it quite a bit less efficient than Fiat-Shamir, especially when the commitment scheme is required to be a length preserving hash function. And that's exactly the thing that we improve upon. We show that this requirement using our reduction is no longer needed. So summarizing, we managed to give the first tight QROM reduction of a Fiat-Shamir based NIZK for the subclass of commit and open protocols. This reduction also works on Merkle-tree based C&Os with Octopus openings. Amongst other things, this applies a tight QROM reduction for the picnic signature scheme. And finally, we give a more efficient version of the Unruh Transform.